Okay, so have you ever just stopped and wondered how all of this came from, well, basically nothing? I mean, we're told the universe kicked off as this perfectly smooth, uniform soup of energy. But just look around you. We live in a cosmos that is super lumpy. It's full of stars, galaxies, the whole shebang. So today, we're going to dive into a pretty wild theory that tries to explain this jump from smooth to lumpy. And you're going to love this. It all starts with popcorn.
It's really the central question, isn't it? Our night sky is just packed with lumpy stuff. Stars, planets, galaxies, these massive cosmic webs. And yet, everything we know points to a beginning that was just perfectly smooth. So what gives? How did the universe get from that uniform, featureless state to the incredibly structured cosmos we see today?
Believe it or not, the answer might just be hiding in your favorite movie smack. Seriously, the theory we're breaking down uses the super simple act of making popcorn as a way to wrap our heads around the creation of, well, everything. So to get this, we have to rewind all the way back, right to the beginning. Imagine the primeval universe in its first moments. It's incredibly dense, it's unbelievably hot, and it's almost perfectly smooth. No stars, no galaxies, nothing. Just this featureless sea of pure energy. But you know that perfect smoothness? It just wasn't meant to last. Something happened. A tiny little crack appeared in this perfect cosmic facade, a disruption that would, eventually, give rise to every single structure in the entire universe. And that brings us to the very first pop. This is the moment where the seeds of everything we see were planted. Not in the ground, but in the actual fabric of space-time itself. These seeds have a name: quantum fluctuations. And here's the wild thing. At the tiniest, most fundamental scales, the universe is never actually still. It's always jittering. There are these constant, tiny, random wobbles in energy. And back in the early universe, these little jitters were absolutely everything. So, to stick with our popcorn analogy, let's think of these quantum fluctuations as the unpopped kernels. They're just scattered evenly throughout the smooth, hot oil of the early universe, kind of waiting for the right moment to change everything. And then, pop. They started to go off. Particles began to literally congeal out of these energy wobbles, bursting from that tiny quantum realm into our big, macroscopic universe. Every single pop was a brand new particle of matter being born.
Right, but one pop doesn't get you a bowl of popcorn, and one particle doesn't make a galaxy. Something had to kickstart a chain reaction, and that something was gravity.
So picture it. One of those little quantum kernels finally pops. And poof, a tiny bit of matter springs into existence, right in some random corner of space.
And here's the really crucial part. The very instant that little piece of matter appeared, a tiny bit of gravity appeared right there with it. You can't have one without the other. Where there's matter, there is always gravity.
So that new little bit of gravity immediately created another wobble, another disturbance in the smooth energy field right next to it. And this new wobble made it way more likely for other kernels nearby to pop, creating more matter and, you guessed it, more gravity, which then caused even more pops. It was a complete runaway effect.
Now, you'd be forgiven for thinking, okay, that's the whole story. Gravity pulls things together, it makes clumps. Makes sense. But there's a huge twist in this story, a mysterious force that was there from the beginning doing the exact opposite. So on one hand, you've got gravity, right? The familiar force pulling all the matter together. But on the other hand, you've got this bizarre thing called dark energy. And you can think of it as a constant cosmic push, like an anti-gravity that's always trying to drive everything apart. So that kind of creates a problem, doesn't it? I mean, if dark energy is constantly pushing everything apart, shouldn't that have stopped matter from clumping together in the first place? It really seems like it would just smooth everything right back out. But, and this is the absolute core of the theory, it did the exact opposite. Get this, the source material says as dark energy, quote, continued to push matter away, it further amplified the tiny perturbations. So think about it like this, by stretching the empty space between the first few clumps, it actually made those clumps relatively denser. It essentially cleared out all the competition, making those first few pops the undeniable centers of gravity. It's a total paradox, but it works.
So now we've got all our ingredients, right? We've got the quantum kernels, the initial pop, the chain reaction from gravity, and that surprise ingredient, dark energy, acting as an amplifier. Let's put it all together and see how this cosmic popcorn recipe builds the universe.
Okay, here it is. The whole process in 5 easy steps. 1. You start with a totally smooth, uniform universe. 2. Tiny quantum fluctuations, our kernels, just appear randomly. 3. Those kernels pop into matter, and they bring gravity with them. 4. Dark energy pushes everything apart, which, weirdly enough, makes those initial clumps even denser. And finally, step 5, over billions of years, gravity takes over in those superdense regions, pulling all that matter together to form the very first stars and galaxies.
And boom, there you have it. The popcorn universe theory gives us this beautifully simple, step-by-step story for how a perfectly even cosmos could end up as the lumpy, gorgeous, structure-filled universe that we all live in. It's a pretty powerful idea, right? And it leaves us with one last, totally mind-bending thought to chew on. If our entire universe started with just one of these pops, what about all the other kernels still out there? In that vast cosmic ocean, what else might be popping into existence right at this very moment?